All right, this is Monday, June 28th, 2021, Math 3 fall term. I'm going to try to teach all of what I would call Chapter 5 from an Algebra 2 book, which is all about the quadratic formula, the quadratic equation. This is a foundation for upgrading and dealing with polynomials of degree greater than 2. All right, so as kind of a review, the first thing is I've listed 3 coordinates. 2, 3, 3, 13, 4, 29. And the question is, are they in a straight line? I see that the change in x from the first point to the second is a value of 1. The change in x from the second point to the third point is a value of 1. The change in y from first point to second point is a change of 10 units. But the change from the second to the third point is a change of 16 units. So that is not a straight line. And so I can kind of already sketch that it's going to be some sort of parabola opening upwards, it would appear. It may or may not cross the x-axis, I don't know yet. But it's some sort of upward opening parabola. To come up with the equation of the quadratic that fits it, I write the generic formula, y equals ax squared plus bx plus c, and now I plug in each of the coordinates. 3 is equal to, and I use 2 for x. 2 squared is 4, so this becomes 4a plus 2b plus c. Plugging in the second pair of points, 13 is equal to 9a plus 3b plus c. Putting in the last set of points, 29 is equal to 16a plus 4b plus c. I suppose I will refer to these as equations D, E, and F. Any subtraction of 2 of these from each other will eliminate variable C. And so that might be a decent first step to do. I could just do, and then, which way will I have more negative numbers than positive numbers? That would be D has the smaller coefficients, F has the largest ones. So if I do F minus D and F minus E, that will eliminate the variable C, and instead of having 3 equations with 3 unknowns, it will reduce down to 2 equations with 2 unknowns. So for F minus D, oh, I'm sorry, what do I need? An eraser. For F minus, I still can't write, can I? For F minus D, this becomes 29 minus 3 is 26. 16a minus 4a is 12a. 4b minus 2b is 2b. And of course, c minus c is 0. That's why I'm choosing to do F minus D. For F minus E, excuse me, this becomes 29 minus 13 is 16. 16a minus 9a is 7a. And 4b minus 3b is 1b. And of course, again, c minus c cancels. Nothing is left. I've now taken 3 equations with 3 unknowns and eliminated the variable c, but I now have 2 equations with 2 unknowns. To go forward from here, I can use substitution. For example, I see very glaringly that b is equal to negative 7a plus 16. And so I could substitute negative 7a plus 16 into the upper equation. Let's see, into the F minus D equation. The other approach, if I want to do it, is I could try to eliminate b by subtracting twice the lower equation from the upper one. Both techniques work. Both of them lead to an answer. So the first way would be 26 is equal to 12 times, open parentheses, minus 7a plus 16, close parentheses, plus 2b. I now have 1, and that it doesn't look like it, but that's supposed to be the number 26. I now have one equation. No, I did that wrong. I'm sorry. This is the beauty of erasing. Oh, yes. I can erase my mistakes before they're recorded, right? So this upper equation, I'm substituting for b. So let me do this correctly. 26 is equal to 12 times a plus 2 times open parentheses negative 7a plus 16 close parentheses. And now I have one equation and only one unknown in it, and that is the variable a. If I multiply through, get rid of those parentheses, I'll solve for a. After I solve for a, I solve for b. After I solve for a and b, I solve for c. The other approach I could take, just as much fun, is I could subtract this entire lower equation. Well, first double it, multiply everything by 2, and then subtract that from the upper equation, and that will eliminate b. So that would be 12. Well, let me do it in 2 steps, right? So first, when I double this, the 16 becomes a 32. The 7a becomes a 14a, and the b becomes a 2b. 2b or not 2b? That could be the question. So now I can subtract either one from either one. In fact, I kind of like it subtracting the upper equation from the doubled bottom equation, just so I don't have minus signs. 32 minus 26 is 6. 14a minus 12a is 2a. And 2b or not 2b, 2b minus 2b cancels. That's why I chose to set it up this way. And so in this approach, it becomes pretty obvious. A is equal to 6 divided by 2, which is 3. So I found one of my 3 coefficients. Again, if I had continued on this way, it would have been 26 equals 12a minus 14a plus 16. And I leave it to the interested reader to prove to themselves, well, heck, let's just do it. If I subtract 16 from both sides, that means I will have 10. And combining like terms on the right, 2a minus 14a is minus 12a. Oh, well, okay. I see a mistake I made there too. This is great. I will just erase my mistakes every time I make them. I didn't multiply through by 2. So minus 14a plus 32. There we go. Now, if I subtract 26 from both sides, you'll see I'm making some progress here. I will have the same answer in the end. A is equal to 3. Hopefully you can see it already. Next step is I can substitute for A back into this equation for B and say B is equal to 7 times 3 is 21, so negative 21 plus 16. So I get B is equal to negative 5. There would be my second coefficient. Now that I have A and B, I plug them both back into any one of the original 3 equations to solve for C. I'll do equation D. 3 is equal to 4 times 3 is 12, plus 2 times negative 5 is minus 10, plus C. Okay, well, so I have 3 is equal to 2 plus C. So 2 is equal to C. It would be wise to verify that in one of the other 2 equations, that we have all 3 coefficients correctly. For example, is 13 equal to 27 minus 15 plus 2? Well, I'll just cheat, look at the answer key, and say, oh, I got the right answer. Writing it 3x squared minus 5x plus 1. Yep, I matched the answer key. Ta-da! That is a fast review on how to find a...
Mr. Turk?
Yeah.
Could you please go over how you got the 32 equals 14a plus 2?
Actually, I'm more troubled about the fact that it's not recording anything. It appears that nothing got recorded. What do you think of that, kids? Let me look somewhere else. Nope. Can't help you, kids. I don't know why it's not recording. All right. So, carrying on, can you please repeat your question? You want me to show you how I came up with what? 32?
How you came up with the 32 equals 14a plus 2b.
Oh, yeah, sure. I can highlight that. I took this and I said, what would it take so that after I do some math operation on this, multiply it, I could then subtract it from the equation that is above it. Here, let's change colors. And have the effect of canceling out b. That's my goal in life. I want to cancel out b. And I looked at this and I said, well, there's a 2b on the upper one, a 1b on the bottom one. So why don't I double the bottom one? And that's where I turned a 16 into a 32, the 7a into a 14a, and the b into a 2b. So I multiplied everything on the f minus e row by 2.
Okay, thank you.
Okay. Any other questions from anyone?
Mr. Turk,
Yeah, don't say
what's it called? The 2 equals C, shouldn't it be C equals 1? Because I got C equals 1.
Yes, it should be. I miswrote it.
Alright.
Okay. Again, that handy dandy eraser. Oh, look. I didn't make any mistakes. 3 equals 2 plus 1. 3 equals 2 plus 1. Ha ha! Well, I'm sorry. 3 equals 2 plus C. That's what it says. 3 equals 2 plus C. Yep. So you subtract 2 from both sides, and I was supposed to get C equals 1. I did write it correctly, interestingly enough, when I wrote it over here. Okay, so that's a fast-paced review of how you find a quadratic equation that fits any 3 points. As long as they are not in a straight line, there is always a parabola that will pass through the 3 points that you are given. I kid you not, always. All right, next. Oh, in this chapter that we're blowing through, one of the characteristics of a parabola, in fact, let's keep working with this one. Okay, this equation, this parabola was y equals 3x squared minus 5x plus 1. And I could ask you, well, does it have real roots? Okay, so first thing, I want to remind you that anytime that a is greater than 0, that means the parabola is opening upwards. You know, I really wish I were recording this. I don't have any evidence that shows that I am recording this. I'm gonna hope that it is, despite everything. Despite everything. Okay, so if a is greater than 0, that means it's an upward opening parabola. If a is less than 0, of course, that means it is a downward opening parabola. And what we can't tell without a little more thinking is, does it have real roots, meaning does it cross the x-axis, or does it only have complex roots, meaning it never touches the x-axis? Okay, so whether a is positive or negative doesn't tell us that answer. But do the following thinking and analysis. Go like this. The axis of symmetry is given by the formula negative b divided by 2 times a. The 2 and the a both in the denominator. Okay, negative b divided by 2a. In this formula that we just worked out, b is negative 5. Okay, so negative 5. And now we're going to take the negative of negative 5. So 5. A is 3. So 2 times 3 is 6. And here's what I want to point out to you. The axis of symmetry is at x equals 5 divided by 6. By itself, that isn't enough to tell us, does it have real roots or only complex roots? But if we now plug this value of x into the equation, then we can calculate the vertex. The vertex will be given by 5, 6, the axis of symmetry, and I think you called it k, the y value when x is equal to 5 over 6. You called this thing h, I think, in some of your work. Okay, so we need to plug in x equals 5, 6. Y equals 3 times 5, 6 squared minus 5 times 5, 6 plus 1. I would personally rather use a calculator. 5 times 5 is 25, and 3 times 25 is 75. 6 times 6 is 36. Here we're going to subtract 25 times 6, and then we're going to add 1 to this afterwards. Well, 25, 6, if I multiply top and bottom by 6 to make a common denominator, oh my goodness, 75 divided by 36, and 6 times 25 would be 150, right? 150, and 6 times 6 is 36, and then add to this 36 over 36. Great. I can see, without actually finishing this off, that the vertex is going to be a negative number. Now, that is all I really need to know to tell you that it has 2 real roots. And the reason why that's enough is because I know this thing has an a greater than 0. I know, therefore, it opens upwards. So if the y coordinate of the vertex is below 0, then the only thing that makes sense is that this is an upward opening parabola that crosses the x-axis twice and therefore has 2 real roots. Now, it's kind of useful for us to go and actually calculate the value of that root. So 75 minus 150 plus 36 is negative 39 over 36. And I think you could divide that by 3. and say negative 13 over 12 is the y coordinate of the vertex. Okay, so I'm telling you, we have the y coordinate of the vertex is y equals, oh, maybe I should switch to graph paper, huh? Since we have it. Okay, switching to graph paper. I'm not going to be real formal here, but let's say there's one axis, there's the other, and let's make this 1, 2, 3, 4, 5 is 1 unit. 1, 2, 3, 4, 5 is 1 unit. So at 1, 2, 3, 4, 5, this would be negative 1. This, of course, is the positive x-axis, and this is always the positive y-axis, and life is good. So the vertex is at y equals 5, 6, which is about here, and at negative 13 twelfths, which is about there. So there's the vertex. I know this is an upward opening parabola. If I want to plot some dots, I could make a table of values and say, give me some numbers for x and for y. In fact, if I put in x equals 0, I should get the value of c, right? C is the y-intercept of a quadratic formula. So here we go. 3 times 0 squared minus 5 times 0 plus 1 is 1. So C is always going to be the y-intercept for these things. There it is. And by symmetry, that's what it means to have the axis of symmetry. So if this, and that dot's a little bit off, if this is 5, 6, and the point 0, 1 is a point on the parabola, there is a corresponding point, another 5/6 of a unit to the right of the axis of symmetry. So 1, 2, 3, 4, 5. That's around here. That is a corresponding point on this parabola. Now, if I were really good, I would calculate something like x equals 1/2 and plug it in and get values for this. Oh boy, maybe we can try that. So for x equals 1/2, 1/2 squared is 1/4. 3 times 1/4 is 3/4. 3/4 minus 5/2 plus 1. That would be 1/4 minus 5/2, which is 1/4 minus 10/4, which is negative 9/4, which is negative 2 1/4. I clearly did that one wrong. Okay, let's agree that I can't do it in my head correctly. I don't know what I did wrong, but I'm going to just use my calculator. Let's see. 3 times 1/2 squared minus 5 times 1/2 plus 1 is negative 0.75. So negative 3/4. So if this 1, 2, 3, so here is this, and then there is that. So that's a point on the parabola. And by symmetry, if I go the same distance off to the right as I went off to the left, which is about this much, there would be the corresponding point. And there's my graph. Yikes. What have I done? I started this period by saying, look, you give me any 3 points that aren't in a straight line, and I can turn that into a parabola. And here's the equation in standard form of the quadratic, the parabola. And if I need to find the vertex, it's negative b over 2a. And then plug that in to get the value of y. If a is a positive number, then I know this parabola opens upward. If the vertex has a negative y value, then I know it has two real roots. Because if it's opening upward and the vertex is below the x-axis, then it must have two real roots. Oh, great. Whatever I just eliminated. I don't know why I did that. I don't know why it's doing this now either. So here was this line, and then I was just trying to show, great, that there was a real root and there was another real root. I know that for two reasons. Reason one, a was greater than 0, which means it opens upward. And reason two, vertex, the k value was less than 0, which means it's below the x-axis and therefore opens up. Let's keep going. With quadratic equations, of course, the vertex is a minimum or a maximum for any type of problem that you have to solve. Word problem. When do you maximize profits? When do you maximize the volume of the planter box? But at least let's just keep going at ludicrous speed. Transforming parabolas. Okay, let's transform this thing. So this equation right now says y equals 3x squared minus 5x plus 1. That is actually a polynomial written in standard form. Notice that we always write these quadratics in standard form for a polynomial. The highest degree written first, and that's the leading term. So this one has 3 terms, making it trinomial. It's degree 2, making it a quadratic. This is a quadratic trinomial. To turn it into vertex form, we established the value of the vertex. The two roots, root 1 and root 2, are equidistant away from the vertex. So the vertex is the average of the two roots. The average of the two roots in this example is 5/6. So when you add the two roots together and divide them by 2, you will get the coordinate of the vertex. And by the way, that's true for any pair of corresponding points on the parabola. Any two values of x that have the same value of y, you take the average of it, and that will give you the vertex. That'll give you the axis of symmetry. I should correct myself. So the axis of symmetry is the average of the two real roots. That's always true. Now, how do we convert this into vertex form? The formula is y is equal to a x minus h quantity squared plus k. So we're there. Y is equal to 3 times open parentheses x minus 5/6 close parentheses squared minus 13/12. There is this quadratic written in vertex form. And of course, we would love for you to be able to factor this. So that's where we can put a lot of time and effort. How do you factor this? We know it has two real roots. How do we establish what are the values of those two real roots? So factoring, different techniques. Yikes, and I'm almost up to my halfway through the period break. So one technique you students may have learned is you put from standard form, you put the A term there, you put the C term there, and you try to figure out what kind of combination of whole numbers can you get that'll work. We're not going to have whole numbers here. The two real roots are between 0. Well, one of them is between 0 and 5/6. So you're not going to have a nice, happy. In fact, we know it's somewhere between 0 and 1/2 based on our data table and our graph. It's between 0 and 1/2. So that is nothing nice to work out with factoring by this technique, I don't think. I mean, maybe it'll work out to be 1/3 x as one of the roots. That's a very good possibility. But I would already give up if I were in a hurry and just go to the one formula that always works, negative b plus or minus the square root of b squared minus 4ac all over 2a. The quadratic formula always, always, always works. You don't have to do anything else. Take your 3-minute break. Okay, just before break, I was saying, look, use the quadratic formula if all else is too inconvenient. So when you do it this way, it always works. So A in this example is 3, B is negative 5, and C is 1, and you just plug them in, everyone. So this becomes 5 plus or minus the square root of negative 5 squared is 25 minus 4 times 3 times 1. And all of that is divided by 2 times a, which is 6. And I'm having a lot of trouble with my little pen here. There must be some button I accidentally poked, which I don't understand yet. So 4 times 3 is 12. 12 times 1 is 1. 25 minus 12 is 13. So this becomes 5 plus or minus the square root of 13. Wow, I just cannot get this thing to behave. 13, all divided by 6. And those are the two roots. I claim that they average out to 5/6. And notice that, look, if you take the average of these two numbers, then these two pieces will cancel. Ha ha! And the average, I claim, is 5/6. Ta-da! Which is the axis of symmetry, which was back up here, 5/6. And now we have the values of those little green real roots. It's 5/6 plus square root of 13 over 6 and 5/6 minus square root of 13 over 6. And if you really want to know what those numbers are in decimal form, that's why we have calculators. 5 plus the square root of 13 is 8.60555125, and then I divide it by 6, and I have, for example, one of the roots is 1.43, and then the other root is the other root. Okay, I'm not going to bother going after it. We have so much more I want to cover. All right, so this is still dealing with quadratic equations. Y equals ax squared plus bx plus c. And I'm hoping you recognize that you can factor this, that you can always use a quadratic equation, and so life is good. But what happens when you have this times anything, really, that it's greater than 1? I mean the whole expression, ax squared plus bx plus c. Now I'm going to create a higher order polynomial, and I multiply this whole thing by x, or maybe x cubed, and then add on a couple of other terms as well, right? So plus 17x, just to be mean. Okay, so then you have a polynomial, and you write it in standard form, which means you always do the highest degree first. In this case, it would be x to the 5th power, because you would be adding these guys here, 3 plus 2. So it'd be something, in this case, ax to the 5th power, dot, 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 dot. Whew. Well, we want you to start off with these polynomials and then be able to work backwards and figure out, gee, if I can get it down to some sort of quadratic equation, I'm home free from there. I could always use the quadratic formula and find the roots. And even if they're not real, even if they're imaginary roots, the quadratic formula will find them for me. So first, a really brief review about complex numbers, okay, and imaginary numbers. I is defined as the square root of -1, which means, great, I squared is -1. And this is mathematically incredibly useful. We wouldn't be able to do engineering analysis without this. Sadly, the condominium that collapsed in Florida was a failure, probably in engineering design. Not sure. They'll eventually figure it out. But maybe it was someone who didn't, take care of their -1 very well. All right. So how do you... I'd kind of like to go over how you graph numbers that are complex. That's something that seems to stump students quite often. I have some number and I write it as a plus b times I. And that means it has a real part, a, and an imaginary part, which is b times I. But the b itself is actually a real number. It's like 3 or 2 or 6 or -8 or square root of 13. You graph it the same way that you would graph XY coordinates. I kid you not.
Mr. Phillip, you
Yes?
see anything?
Oh, you can't see anything.
No, and also you left the meeting, so I'm kind of lost on what you're talking about.